Hi, everybody. Welcome to the Shiko SAT review series. And in this topic, we're going to talk about is the linear equations here. Okay, as we mentioned at the beginning, when we start this topic, linear equations, we said the SAT exam covered a lot of the linear equation type of the problems here. So the first unit we talk about is how to solve the linear equations. And then this unit, we're going to take a look. It's very similar, like how to solve the linear equations problems. It's like how to switch the variables in a given equation or formula. And on average, like since every SAT exam, they always have one of those type of problems, and those type of problems are kind of easy problems. So those are the easy credit to get as well here. Okay, so this video should be a pretty quick video because if you know how to solve the linear equation, then this one, it's a pretty easy. And also, I think, the reason why the SAT cover this topic, and because later, if you are going to the physics or chemistry club, and the class, like the typical, the first things, the first chapter, they will ask you to do is like switch the variable for given formulas, right? So it's very useful tool you'll be able to use in your other fields here. Okay, so let's take a look at our worksheets, all right? And then we're going to work the problem and see what type of the problems, will be put in the SAT exams here. So, okay, I'm going to the problem sets here. Let me see, where is my problem set? Okay, here we go. Okay, so hope you can see this, right? So for here, we have 7 problems here, and they show you how to switch the variable in a given equation or formula. Like I told you before, from the previous unit, how to solve the linear equations. If you know how to do this, this unit will be a pretty easy unit here. And you will see all the problems are very easy. And I think that the things that get to the student is sometimes the problem is very wordy, it's have a word problems, and a lot of times the student get scared, and but it's very easy type of, if after you read it and how to switch the variable, it's very easy. It's kind of like similar, like how to solve the linear equations here, right? So the same concept. Okay, let's take a look at the number 1 here. So let's say the volume of a sphere is given by the formula V is equal to the 4/3 pi r cube. R is the radius. So which of the following give the radius of the sphere in terms of the volumes here? So here, the problem gives us V is equal to the 4/3 pi r squared. Pi r cube is here, right? So what do they want to do here? They want to give the radius in terms of the volumes here. Okay, so what's that mean? So that means I need to find the radius, right, in terms of the volumes here. That's what it means here. I want to change the volume of the radius in terms of the volume. So what I need to do is here, well, just like we solved the linear equations, right? So let me see here. So you say, okay, I need to get rid of this fraction. So I will times the 3/4, and here I will times the 3/4 on the both sides, right? Okay, so after time the 3/4, so 4 and the 4 and the 3 and the 3 cancels, right? Okay, so that's why you have a 3/4 V is equal to the pi r cube. And then what is the next thing you need to do? You divide it by pi. So here you divide it by pi. So this is the 3/4, and this is the V divided by pi. So this is the r cube. So here, because this is a 3/4, right? So 4, this is this is the place some student will make mistake. Okay, so here, this is the 3/4, right? So 4 is in the denominator. So here, this is a 4 pi, and this is the 3V's, right? Okay, so now this is the what is here? R cubed. So what do you do here? You take the cube roots here, right? So you take the cube roots. So that's why you can say R is equal to what? 3V over 4 pi. And here is the cube roots, right? So now let's take a look at where we have here. Here is the answer. So for these problems here, the keys here, you need to know like after the 3/4 of the V, you divide it by pi. And then because the 4 is on the denominator, so that's why here is the 4, right? So just be careful about that, and then I think you'll be fine. See here. Okay, let's take a look at the second part. See here, right? The second part, they tell you, they said the density D of an object is found by dividing the mass of the object by its volume. All right. Now, which of the following equation give the mass? Now, I'm trying to solve the mass in terms of the D and the V. So the first part, that's we need to write out the relation. You know, the problem tells us, they said the density D is find dividing the mass of the its volume. So basically, we say D is equal to the mass divided by the volumes, right? And then now I say, hey, I'm going to find the M, right? I'm going to find the M. So how do I find the M? See here. In order to find the M, just like we solved the linear equations here. So what do we need to do? We need to times V both sides, right? When you times the V, so this V and this V cancel. So that's why you will get the M is equal to what? V times D, right? Or D times V. You can write this is D times V as well. So what is the answer? It's 8 here. Okay. Right? Okay, so I say as long as you write it out. So this problem, the SAT try to test you is, can you read the word problem and then put it into the equations and then understand what it wants you to do? Okay, number 3 is here. Okay, so the number 3, they ask you the bricklayer use the formula N is equal to the 7LH to estimate the number of the bricks, right? So the number of the bricks is N to build the wall that is L feet long and H feet high. So which of the following correctly expressed L in terms? So that means which number I'm trying to solve here? I'm trying to solve for L's, right? So in here, after you read the problems here, so it's 7LH here, right? So after you read that, you say, oh, okay, so I'm trying to solve it for what? I'm trying to solve it for L. Okay, if I'm trying to solve it for L, what I need to do here, like we did, so I need to what? I divide by what? 7H, right? So if you divide 7H on the right-hand side, you need to divide it by the 7H on the left-hand side. So now here, the HH cancel, 7 cancel. So your L is equal to the N over 7H here. So which answer is N over 7H? So L is equal to N over 7H. So it's here, right? So it's a C here, all right? N is equal to the 7H. Okay, now let's moving pretty fast, right? Like I say, those are pretty easy problems, right? So the problems here, you know, when you look at the word problem, don't get scared, and then you know, so if you read it and set it up, then it's pretty easy to solve here. Okay, now here, this is the problems here. Okay, so I put the 4.1, 4.2, because in the SAT, sometimes they will have the 2 problems really related to each other. This is one of those. Okay, so they said the current, A is the current formula, and is equal to 4 plus W over 30. Okay, so this is the current formula. So let's say, what is W's, right, in terms of the A? So here, this is A is equal to 4 plus W over 30s, right? So when you read the problem and say, what is the W? So that means what I'm trying to solve in here. I'm trying to solving for what? Solving for W's here. Okay, so as always, I'm trying to solving for W, but I have fraction 30s here. So what I need to do? I need to do what? I need to times the 30. So I can times the 30, both sides here, right? The reason why I want to times 30 and the 30, then I can cancel this. So what I have here, I have a 30A is equal to what? 4 plus W. Now you minus 4 minus 4. So what is the W give you? 30A minus 4 here, right? 30A minus 4, good. So what is the answer here? A, so it's an 8 here. Okay, so let's take a look at 4.2. So they said Morse-Taylor's formula, they have a different way try to represent the currents here. So they said Morse-Taylor's formula is A is equal to square roots of HW over 60s, right? So they said if the Morse-Taylor's rule and the currents rule, they give the same estimate for the A. So which of the following is equivalent to the expression for the square roots of HWs here? So they said both those formulas, right? Both formula and the current formulas here and the Morse-Taylor's formulas, they give you the same. That means A equal to A, right? So here, take a look here. So this is the current, right? So this is the current, right? So A equal to A. So what does that tell me? So let's tell me is the 4 plus W equal to the 30 is equal to what? Equal to the 60 of the HW. And then the problem asks here, which of the following is the expression of the square roots of the HW? That means I'm looking for this part, right? The square roots of HW. Then you say, oh, the square roots, but the square roots of HW have fraction divided by 60. So what I need to do? I need to times 60, right? So you times 60 on the right-hand side, you need to times 60 on the left-hand side. So 60, 60 cancel. Then 30 and 60 become how many? 2s, right? So that's why your final answer, that means HW is equal to what? 2 times 4 plus W's here. Okay, so it's a pretty, it's pretty straightforward, right? So you just need to read the problem. What do they ask you to do? Okay, so number 5 is here. Let's take a look here. So the number 5, they tell you the formula below is given by a project manager to compute the E is the estimated time to complete the job. So O is the shortest completion time, P is the longest completion time, and M is most likely completion time. So which of the following will be correctly given P in terms of the E, O, and M? Okay, so let's do here. So this is E. So what is it tell me? This is 6 O plus 4N plus P's, right? So when you read the problem, they say, hey, what is the exactly the given the P in terms of the E? That means which number I'm looking for? I'm looking for this one. Try to solve for this one here. So how do I solve for this one? Oh, this one, the whole thing divided by 6, like we mentioned, we said, hey, every time we see a fraction, we always want to remove the fraction, make it easier to do it. So what do I need to do? I need to times 6. So I need to times 6 here, right? So 6 here you cancel, all right? So that's why we cancel out the fraction. So let's have a 6E is equal to the O plus 4N plus P. I'm trying to solve in for P, so I need to minus O both sides. So this is 6E minus O is equal to this 2 cancel, right? So it's 4N plus P. I still need to minus what? Minus 4N minus 4N right? So I have 6e minus O minus 4n is equal to what? Is equal to p, right? So let's check to see which answer we have 6e minus O minus 4n. Oh, hey, here we got here 8, right? So that's the A answers here. All right, we're doing pretty good, moving along very well. Okay, let's take a look at number 6. This is type of the problem. When you look at this problem, most of the students, when they see this big formula, they will just get scared. So they probably will skip it, right? But if you look at it, that's why, you need to, like I always say, you pick your battle to fight, right? So for here, you look at it quickly to see, maybe this is just an easy problem and they just want to scare you. So they said, okay, the formula above gives the monthly payment N to pay off a loan in dollars at the R% annual rate, capital N months, which of the following given the P in terms of MR and N. So you say, oh, here I'm looking for is these numbers, right? So that means, oh, I'm trying to solving for the P's here. So how do I solve for the P instead of, these things, right, looks scary, but it's just a fraction. So you say, oh, I know that. What I can do is here, I can just, like if you have, for example, if you have a 4/3 P, how do you get rid of the here? You will say, hey, I'm just times the 3/4, right? So you just times the reciprocal. Then you can cancel that out. So here is the same, see here, right? Okay, so I mean right here. So here is the same. I just need to multiply the reciprocal on the both sides here, right? So here, the whole this side, I need to just multiply the whole this things here is 1 plus R1200 to the n minus 1. And this is 1 over 1200. And this is 1 plus R1200 to the capital N here, right? So basically, I just times the reciprocal of whatever, right? So this is what I call it. This is the whatever this constants, right, in front of the P. It looks scary, but it's not. Okay, so the same way is here. When you times the, these things, so what do you need to do here? You need to times the same things, right? So this is 1 plus R1200, the capital N minus 1. So this is R1200 and 1 plus R1200 N's, right? So which answer is that? Let's take a look here. Which one is exactly matched here? It's the B's, right? So let's B is our answer. So for the problem 6, I know a lot of students, when they see this type of problem, they will skip it immediately because it looks so scary. But like I mentioned before, in many, many different units before, like I said, SAT problem in general are very simple and basic. And then they try to, like trick you or try to kind of scare you, to see this big formula. So, but after you see this big formula, you read the problem, then you say, oh, it turns out this is really very simple problems here, right? Okay, now let's take a look at the next ones here, right? So the next ones here, it has 2 parts, and so let's try to finish here. So let's say the speed of a sound wave in the air depend on the air temperature. The formula above is a relation between the A is the speed of the sound wave and the feet per second, and the T is the temperature in the degrees of the Fahrenheit here, right? So in here now, let's try to be careful. Read. They say, which of the following express the air temperature in terms of the sound wave? Okay, so in here, so this is A equal to 1052 plus 1.08 t's, right? So they did not really specifically say, hey, find the t, but they did say, hey, let's try to find the air temperature. So what I'm trying to solve in here is here, right? So then the problem becomes pretty simple. It's just like you solve for the linear equation. So what are the first things I need to do? I need to divide it by 1052 both sides, right? So this is e minus 1052. So this is 1.08 t. What is the next thing here? Divide by 1.08, then divide by 1.08. So in here, 1.1 cancel. So what is my t's here? T is equal to a minus 1052, 1.08. Okay, now let's check our answer to see which one is. Did you find it? So it's a minus 1052 divided by 1.08, so it's the a's here. All right. Okay, so now the second part of this problem is here. So let's say, which of the following air temperature will the speed of the sound wave close to 1,000 feet per second? Okay, so in order to find this problems here, so basically they tell you here, right? It's like they giving you this 1,000, and this is the sound waves here. So basically they say, okay, after I find it, I find the formula for the t. Now, when the a is equal to 1,000, what is the value, right? So this is what give you here. This is 1,000 minus 1052. This is 1.08. So I'm getting the negative 48.15. Okay. So the negative 0.8.15, which one is the closest to this one here, right? So this is the answer. Okay, so that's it. Like I told you in the beginning of this video, this is a very short unit, under the linear equations, right? So like it's kind of like very useful, later when you're taking the physics or chemistry class, you will be able to, switch the variable around here. But they are also very easy topic. You should be able to grab the credit. I guess the only things in here is, you need to read the problems, and sometimes they give you a very, very complicated formula that scale you, but it turns out it's pretty easy to do. You just need to kind of glance through the problem fast to see, is this is the easy one? Then if this is the problem about the switching the variable, then you should get the credit for that. Okay, so that's it for this unit, and very nice to talk to you about this one. So I guess I will talk to you later in the next unit in the linear regressions. Okay, so you guys have a good day, and work hard. Okay, looking forward to talk to you in the next video. Don't forget to subscribe to the channel so you will get the notification if the new video is posted. Okay, so nice to talk to you, and have a good day, and I'll talk to you later. Okay, bye-bye.